This video is all about solving geometric problems using vectors. So in this question here, I'm told the position vectors of 3 points A, B, C are 3i plus 4j minus k, 2i minus j plus 2k, and 4i plus 2k, respectively. So A, B, C. And I need to work out the area of the triangle formed. So let me draw a little sketch of what's happening here, and then we can start doing some calculating. So I'm just going to draw these points in any old positions, A, B, C, partly because we're in 3 dimensions here, so it's pretty much impossible for me to draw it accurately anyway. So I'm just putting these in random places. I know that the position vector of point A is 3, 4, minus 1. I'm getting that from here. The position vector of point B is 2, minus 1, 2. And the position vector of C is 4, 0, because notice there is no j component here, it's just 4i plus 2k. So 4, 0, 2. So those are the position vectors of each of the vertices of the triangle. I'm now going to work out the vector A to B. So that's going to be the vector B, take away the vector A. So B take away A, so I've got 2 take away 3, minus 1 take away 4, and 2 take away negative 1. So that's the vector A to B. Now the reason why I've done that is now I can work out the magnitude of that vector, which will tell me the side AB, the side of the triangle. So if I do some Pythagoras on that now, minus 1 squared plus minus 5 squared plus 3 squared, all square rooted, is root 35 in surd form. So I know one of the sides of the triangle. I'm now going to do the same with the other 2 sides. So let's do the side BC, the vector from B to C. I'm going to do the vector B to C. If you wanted though, you could do the vector CB. It doesn't matter which way around you do this because we're going to do the magnitude in a minute anyway. So it doesn't matter the direction. I'm going to do B to C though. So the vector the vector C, take away the vector B. So 4 take away 2, 0 take away negative 1, and 2 take away 2. So that is the vector B to C. And then finally the vector A to C. Again, you could do it the other way around if you wanted to. You could do C to A, but I'm doing A to C. So C take away A, 4 take away 3, it's 1, 0 take away 4, it's negative 4, and 2 take away negative 1 is 3. Just doing the magnitude of each of those vectors then. So so 2 squared plus 1 squared plus 0 squared, all square rooted, is 5. Then 1 squared plus minus 4 squared plus 3 squared, all square rooted, is root 26. So I have now worked out the length of each side of this triangle. I can now use that to help me get the area. Remember the formula for the area of a triangle is a half AB sine C. So I need to work out an angle to help me use this formula. I'm going to work out this angle here. You could do any of them, it does not matter, it's entirely up to you. So to work out that angle, I'm going to use the cosine rule. So I'm going to say cos theta. So this is going to be, remember the rule for this, so the general Cos rule, and I'll put a link in the description of this video so you can see, remind yourself of the trigonometry rules if you need to, but hopefully you remember the cosine rule like that. So cos theta would be root 26 squared plus root 35 squared minus root 5 squared, all divided by 2 times root 26 times root 35. Remember, the key thing is that we're taking away the side that is opposite the angle you're working out. In this case, the root 5 for me. If I type all that into my calculator, I get 0.928. And when I do cos inverse of that, so cos inverse of 0.928, so I can actually work out the angle, I get 21.8. So this is 21.8. I can now use the area formula, the half AB sine C. So half of root 26 times root 35 times sine 21.8. Remember, when you are using this formula, the two sides that you use need to be either side of the angle. And when I type that into my calculator, I get 5.61, and I'll just call it units squared. And there we go. So the point is with this question is, by writing down the position vectors at the beginning, I can then work out a vector for each side, when I can do the magnitude to work out the length of each side. And once you know the length of each side, you can then use your basic trigonometry rules to solve that problem. Right, second example looks like this. We're just in 2 dimensions here. The coordinates of A, B and C are 3, 5, 4, 8 and 11, 6 respectively. Find a point D such that ABCD is a parallelogram. Right, so A, B, C. So there's my ABC. I'm going to guess that D is here. A, B, C, D. This is my parallelogram. Notice I'm not even particularly trying to draw these coordinates accurately, because I don't have to. You can draw it accurately if you want to, but in terms of the vectors, the vectors will sort themselves out. So the position vector of A was 3, 5 from here. The position vector of B was 4, 8, and C is 11, 6. Again, you're probably looking at that and saying that doesn't make sense, but in terms of the, that doesn't look right. I'm not trying to make it look right. The diagram's just helping me to figure out how I'm going to use the vectors. Because looking at my diagram, I'm now thinking that the vector BC is C take away B. From B to C is C take away B, so 11 take away 4 is 7, 6 take away 8 is negative 2. And because it's a parallelogram, this has to be equal and in the same direction. That has to be 7 minus 2 as well. If this is the point 3, 5, and I am adding 7 to the x coordinate there, that would be 10. And I'm subtracting 2 from the y coordinate, so that would be 3. So A point D could be 10, 3. The coordinate 10, 3 would make this a parallelogram. Notice it says A point, it doesn't say the point, because there are other answers to this, and you could be asked to find what those other answers are. So, actually, I won't rub that bit out. Let me just rub out where I marked point D on. Oops. So here are my points A, B, C. Where else could D be so that we have a parallelogram? Well, I could also mark point D on up here, roughly. Here is my A, B, D, and C. Roughly. It doesn't quite look like a parallelogram, but hopefully you get the idea. And I can again use the same method to help me to work out the coordinate of point D there. The vector AC is my C take away A. 11 take away 3 is 8. 6 take away 5 is 1. And because it's a parallelogram, this vector here also has to be 8, 1. And so my point D would be 4, 8 plus 8, 1, so 12, 9. So a coordinate 12, 9 would also make a parallelogram. There is one more of a coordinate, point D, that could give you a parallelogram. I'll let you find that yourself though.